Panasonic RF-2200. Truly a classic in my books. I've always wanted one. I finally got around to getting one, and this is a pretty good example. The antenna is all in one piece. The bar antenna is working. Unfortunately, put some new batteries in it, and this is all we get. And none of the controls work. You know, I don't hear any kind of static. Doesn't matter what band we're in. Nothing. Just doesn't work. So we're going to have to try to see what's wrong, and hopefully it's something simple. Okay, I've taken the back off of it. You can see there's some battery corrosion, but nothing terrible. And really, the radio looks pretty good inside. So we've connected a power supply. I just want to see if it's drawing any current when you turn it on at all. So here's our power supply in the back. You can see it. Hope you can see it. Let's get things a little more lined up. Let's see what happens. Turn it on. So we had a quick little flash of current. Now it's sitting at about 22 milliamps, which I guess with no sound would be okay. But there's absolutely no sound from turning the volume control. Nothing when we switch between the different bands. You would think on basic AM you would hear something. But there's just nothing. It's completely dead. So let's look at the stupid things first. Let's check the make sure that we don't have a problem with the headphone jack and things like that, because sometimes the headphone jack will get cruddy and it'll prevent you from hearing the sound at the speaker. Okay, so it's drawing a nice consistent 22 milliamps, and none of the controls affect that. If I go to the power switch, this little switch for when you plug in, you know, for the AC, if you look up at the current meter there on my power supply, I push it in, it goes out, let it go, I hear the little pop from the speaker, and it turns back on. So it's not that. If we just take a earphone jack and plug it in and out, I don't hear any kind of popping or scratching. So it's definitely not something like that. So it's got to be something not related to, at least to the sound here at the end. I have a feeling it's going to be something else. We'll see. All right, with the front off, turn it on. If I put this down, the light works. So we are getting voltage out to the board at least to that part of it. Haven't looked at the schematics yet. I have those out. I haven't printed, but I just haven't looked at them yet. Okay, just a minor distraction from our troubleshooting here. I just got to bring this up to you. Talk about quality. Here's the integrated circuit, which is the amplifier, and you can see it drives a transformer that drives the speaker, but take a look at the volume control. It uses a tapped potentiometer with loudness contour. I mean, talk about quality. This is a really cool little radio. Okay, I have my little bench test speaker connected to the speaker terminals. And what I'm going to do is I'm just going to take this little wire. I'm going to hold this part in my fingers, and I'm going to touch the base and the collector of TR21. We're going to just see if we can inject some sound into the amplifier. I just want to make sure that this amplifier chip is not bad. That would be pretty devastating if it were. Okay, here we go. Onto the base. Very, very quiet. I don't even know if the microphone's picking it up, but I'm getting a buzz. If I go to the collector, all kinds of amplification there. So, that being said, I can get signal on the collector. I have a very loud signal. On the base, I have a very, very quiet signal. Do we have a bad transistor? I really doubt that, but I guess it could be. So here's the base again. Yeah. So you would think that if I touched the base of this, it would blow your eardrums out, but it's blowing your eardrums out when you touch the collector instead, unless the screen printing on the board is incorrect, because it's saying that the collector is the middle pin. I don't know if you can see this down here. Let's see if we can zoom in. You can see very clearly the collector is the middle pin, and that's very loud when I touch it, but the base is that top pin, and it's very quiet. So it's almost the opposite. So now we have to check and see if the printing is incorrect on the board or if we have something wrong with our transistor. Okay, I don't know if you can quite make that out or not, but this is a 2SC945, which is just a very basic common transistor, NPN. And if we look up in our transistor guide, 2SC945, and of course it's showing emitter collector base. So it is showing the collector in the middle, the base on the top, and it is in the same direction as this is showing. So in fact, that transistor is not amplifying. Now let's check and see if we have some voltages there, because we haven't checked that yet. Okay, according to the schematic, we should have 0.7 volts on the base. We should have 0.2 volts or 200 millivolts on the emitter and 1.8 volts on the collector. So let's see that if that's what we're getting. Okay, here we go. Base, nothing. Collector, nothing. Emitter, nothing. So is it that I'm not getting a good ground? Let's look and see. Let me connect my meter to the battery ground. Hold on. Okay. Just making sure I'm not crazy. If we touch the input, we got 6 volts. You saw that. So again, we go to our transistor. Nothing on the base. I hear the buzz of the speaker, but nothing on the emitter, or I mean on the collector. And nothing on the emitter. So there's no voltage getting to that transistor. Why? All right. Let's find out why. Now it appears as though there is a voltage regulator transistor right here. Let me move this light out of the way. Right here. Comes up, you have your batteries, goes through the switching, comes up through here, goes to here, and we should have some kind of voltage there. And if you look, the integrated circuit is powered before that transistor. So this is TR24. So TR24 is going to be down by the power supply somewhere. And there's a transistor right there. Let's see, and I see it number 24. Let's see if we can zoom you in a little bit more. And there it is, TR24. Okay, so let's take a look at that and see if there's a problem there. We might be able to get that from the rear of from the other side of the radio. So let's flip it around. I'll be right back. Okay, who's the wise guy that put this plastic piece in the way? The transistor's down here at the bottom. And if I look at the base of the transistor is 4.5, and according to the schematic, that's right about where it should be, I think. The collector is 6 volts, and we have 6 volts. And the emitter is 4.9. Or I'm sorry, I have the emitter and base swapped around. I'm measuring them backwards, but yes, I have my voltages. But I do not have it on our transistor. Okay, so if we follow along, here's our regulated voltage. It goes through R96, which is a 1K resistor, and that's the resistor right by that R20 or TR24. So that's this. And then it gets filtered through a capacitor. And then we have R92, which is a 33K resistor. And on that side of the resistor, I should see something. So I need to check both sides of R32. And I should have, I don't know, somewhere in the line of, my 5 volts or so here. And I should have my 1.8 volts here. So 5 volts, 1.8 volts. So R92, there's R92. If I look on one side, let's see here, get the meter in where we can see it, huh? So R92, one side of it, nothing. The other side of it, nothing. Now how about that? I don't have anything there. But if I go to this 1K resistor, I have 5 volts on one side, and I have 6 volts on the other side. Am I looking at the wrong resistor? That's entirely possible. Let's look a little closer. That is, let's see, R104. Is that what they're calling that? No, I'm looking for R96. So I am not looking at the correct resistor. That is the problem. So where is R96? R105. Let me find R96. I'll be right back. Okay, I was looking at the wrong place. R96 is right here. And if we look at that, there's 0 volts and 0 volts. So I'm not getting this voltage from the transistor over here to R96 over here for whatever reason. And looking at the schematic, according to this, there should be just a direct connection from the emitter of R24 straight down here to R96, and I'm not getting that. Why are we not getting voltage to that? That's the question. All right, I don't know if you can see this, and I don't even know if this is something significant to the problem because I'm not sure what trace is what. But if you look down here, I see battery corrosion right there. So let's clean that off with some alcohol first. Maybe this is just a wild goose chase on this, but nevertheless, I don't want that corrosion on there, so we'll clean it. Aha! Look at that. It's not coming off. That's not coming off. Actually, the trace is coming off. I don't think we have continuity through there. I think the battery terminals, so I think somebody had leaky batteries. You look up here on the pot, there's more of it up here. Wow. Let's see if I can find a little scratch brush or something that I can clean a little better with. I'm going to clean the screening off on this. We can always put some, I have some conformal coating that I could paint on there. But I'm going to clean this off, and I'm going to see if we have continuity all the way across here, because this trace looks pretty bad. Let me do that. I'll be right back. Okay, pardon the sideways meter, but if I touch from here on this bottom trace to here, I'm not getting much of anything, am I? There. Now I have continuity, but it's kind of sketchy. If I go back a little bit, I have pretty good continuity. If I move up to here, I still have it. If I move over to here, I don't have it. See that? It's mega ohms. And you can see this section right here is where it's worn off. It ate all the tracks away. If I go here, I have it. You see it on the meter. Go to the other side of that, it's gone. We have a bad trace. I think that's our problem. So let's see what we can do to clean that up. Yeah, see, it rubbed that trace right off. It was so thin, you can see the top trace didn't rub off, but the bottom one did. And therefore, that trace was just, it was so paper thin, it was almost completely gone. So I think what we're going to do is we're going to run a piece of wire right along there. And I think that will be the most prudent way to handle this, because, again, this is pretty badly damaged. I mean, I can see all the way back to here. The trace is just, it's so paper thin. That battery acid just ate it away. We're going to have to clean this up here on the pot as well, or the same thing's going to happen to this if we don't do something. Okay, put my microphone on. Alright, I'm going to clean off any of the old flux or anything from this trace. And this bottom trace of the transistor is where we want to tack onto. That's a pretty solid area there. I've tinned this wire, and I put a piece of heat shrink that will not melt. It's high temperature heat shrink, and that's going to help us out a little bit. Now I'm going to put a little bit of flux on there. I'm just going to barely tin this like that. And then I don't know if I can do this around the camera, I will. If I cannot, I'll have to move the camera over momentarily. Let's see what we can do. I think I got it. Nope. Let's try again. Yeah, this is kind of tough. Let's see if we can get it from this angle. Ooh, there it is. Oh wow, I got it perfect. Perfect. Okay. One down, one to go. Another town and one more show. What's that from? Do you all know? Good grief, this is turning into a soldering chat, and I never even planned for it. That's okay, we like that. It's fun. At least for me it is. I like talking to all of you. All right. So we're going to take this over here. I'm going to cut an appropriate length. And then we're going to bring this up. Okay, let's see if we can do this without bumping the camera. No guarantees on that. Let's see here. This vinyl insulation on the wire will just melt and shrink away, and the next thing you know, the little piece of conductor that's sticking out will end up being a long piece of conductor, which is not good. Okay, and we want to connect, and I know I'm going to hit this plastic a little bit. I just don't want to take this whole radio apart if I don't have to. So let's get this through here. Let's get a little drop of solder on there. We got it. All right. Okay. Let's see if we can handle this. This is where I melt the case. Ha! How about that? Well, every now and then, even a blind squirrel finds an acorn, as they say. And then I just want to make sure we don't have any shorts because everything's very tight in there. I don't think I do, but let's just clean this out really well. No, it actually looks good. But we are going to take the meter and just make sure. So I'm going to go from here to here. If I can hold that while I move to look at the meter. Very good. Okay. So that repair is complete. And what I'm going to do now is I'm going to move this up. And I'm going to verify that this top portion is also good. Because if you notice, the solder doesn't want to stick to that either. And usually when solder doesn't want to stick, it's because the copper has been badly oxidized. Although up that high, it didn't appear to be. So let's see if I can flow a little bit of solder on it. See what happens. Oh yeah. See, this one's behaving a lot better than the other one. Okay. There you go. And now what I'm going to do is I'm just going to put some conformal coating on there to keep it from corroding again. I'm going to make sure all of this is good. Clean it off with some alcohol. And then I think we'll be good to go. Nice. Right? Right. Okay. Let me get the conformal coating. I'll be right back. Okay, this is good stuff. There it is. And then let me just dry this off a little bit. So I still have some alcohol on there, I'm sure. Oh yeah. Let's just sop that up a little bit. There we go. Nice. Okay. And then we'll just put some of this on there, and that'll kind of help hold everything together. And hopefully that's all this radio needs. I mean, you know, we can go full-on capacitor cowboy on this too, but I don't know that I want to recap it. It's a lot of work, unless the performance of the radio has been compromised, but we'll see. Okay, let's see what happens here. Ready? Ha! Success. Sorry I ripped your eardrums out. Of course, there's no antenna or anything, and I'm not going to get anything down here, but it works. That's what it was. Broken wire. Or broken trace. And you can see all the battery corrosion down there. And the funny thing is, the battery terminals are not bad. Okay, the conformal coating is dried, and I got all of the, or most of, I should say, as much as I could get, of the corrosion out of there. And honestly, the best thing to use to get rid of that battery corrosion is just plain old vinegar, white vinegar. It will just completely dissolve the corrosion and get it down. You can try to spray it with contact cleaner and you'll find out it will do next to nothing. As soon as you put the vinegar on it though, it immediately dissolves. So it's the best stuff to use. It's cheap and it works really well. So I did that. Little tiny spritzer of deoxit green in the pots and a little tiny spritzer of deoxit red in the switches to make sure those are all good. And well, we're ready to put this together and give it a test. Okay, we are all put together. I have a antenna connected to the back. We will turn it on. Hey! Okay, so that looks good. Let's go to AM. And it's quiet. The meter's moving. See the meter moving? Volume's all the way up. Listen. And that's all I'm getting. Okay, so AM is not working. Let's go to shortwave. Ooh. I can hear it. I don't know if you were hearing that. So we're getting it, but it's just really, really quiet. We still have a problem. I think I put this radio together too soon. All right, well, you know what? Before we take this apart, let's look at the schematic and see what could cause this, because it seems like the FM works. AM and shortwave are extremely quiet, but with the meter action that we're getting, it looks as if it's able to tune, but we're just not getting the audio once again. I wonder if we have another bad track or something. Let's take a look. Of course, this is your typical radio that was sold, you know, working, good condition, blah, blah, blah. Just never trust anything. I don't, and that's why I'm not even surprised. So anyway, let's see if we can figure this out. This is kind of a neat radio in the way it's designed. Our FM section is up here. Anything AM or shortwave is down here. If we look, we have switch number 1 to SW1 or S1. So here's, and it's a multi-deck switch. So this first deck you can see is switching between shortwave, medium wave, and FM. And this is another part of switch 1, and switch 1. So all these are together. They're one switch, and so is here, number 3. So these are all the same switch. And another section to it. So there's 7 sections to that switch. And what it looks like, here's your antenna coming in. And where's the gyroscope antenna? It's in here someplace. I think it might be this one, not sure. So here's your short wave, the RF tuning for each one of those. This appears to be AM RF amp. So here we have a JFET, and it goes into, that actually affects the short wave and AM medium wave. We also have a switching transistor here that you can see when you go to medium wave, it goes into the base. When you go into short wave, FM, it grounds this out, and short wave, it's connecting down into here. This is a dual conversion system. So if you see, there's shortwave first oscillator, and then you have a shortwave second oscillator and your AM oscillator. Let's break this schematic down a little more. All right, looking at the block diagram, this was in the service manual, the page just before the two schematic pages. And if we look, I took some notes and highlighted a few things that I noticed before I printed this out. First of all, this is a dual conversion shortwave radio, but it's a single conversion for AM and FM. So FM is your traditional 10.7 megahertz IF. Your medium wave is 455 kilohertz, just like all the others, and you can see that's this down in this section. And then if you look here is your first IF, which is your 1.985 megahertz. So what they're essentially doing is, for shortwave, they're creating a first IF at 1.985 megahertz. And then once it goes through that, it gets mixed down once again to 455 kilohertz. In addition, you have two different stages of tuning in there. Now, I don't know if that's stagger tuned or not, but we'll have to look at that. I don't think it is, though. I just think there's two different stages of filtration, and they're both tuned to the same peak. I don't know if I'm going to get into that or not. I wasn't really planning on it, but who knows? More important, I'm kind of prattling on here, but this section that I circled, you have an RF amp, which is this little JFET right here. And it's also connected to your gain control, which is down here. You can see the gain pot, and it goes up here to this transistor, which goes up into the drain of your your RF JFET, and then it goes into your oscillator mixer and all that. Let's look at this JFET, because usually if a component's going to fail like that, it would be the JFET and not the transistors. These are those switching transistors as well. They could be bad, or we could have another bad track. So either way, we're going to have to take this radio back apart. Okay, I have the signal generator at 1 megahertz with a AM modulation, 100 microvolts. And I'm just going into a loop antenna here, just a coupling loop over the bar down here. And I'm just going to see if we can tune something in and see it on the meter at 1 megahertz. I have the volume turned all the way up. And look at that. It's right on too. Look at that. That's pretty spot on. 1 megahertz. I can hear it. I've got the volume all the way up. And you can see the RF gain is working. And if I listen, if I put the microphone right next to the speaker, let me do that. You can hear it's very, very quiet. So once again, we just have reduced audio, but it seems as if the IF, RF, and everything is working. We're just not getting any kind of output to our audio again. So I wonder if we have another bad trace. Let's look some more. Okay, the fact that we're seeing meter movement and that we can hear a tiny little bit of sound and I can tune right on frequency tells me that all the IF sections and the RF sections, everything are working. So we're really narrowed down to switches. And the one thing, I had these 3 things circled, and we're over to this switching transistor, and it is TR19, and I'm wondering what kind of shape it's in. So I'm going to go here and try to locate it and see where it is. Let me look for it. I'll be right back. Okay, after a little bit of searching, it appears as though it's right here, TR19. Let's go to diode check. Let's put this down where we can work on it. Okay, that is an NPN transistor. It appears. Nope, it's a PNP transistor. So the N lead goes on the base. And let's take a look at this here. Well, let's move this where I can see a little bit. Okay, so I have a diode drop there. That's good. And a dead short between collector and emitter. You see that? We have a collector emitter short. Now, is that because of the switches? Collector emitter. It appears as though this collector and emitter is right across this coil here. It's kind of hard because they put this dark line in here for, to show you a signal path. But I believe what they're trying to show you is that the collector and emitter go across this coil, and if they turn on, that will bypass this and turn on this one down here, I guess. I think I'm going to pull that transistor. We can't really test it properly unless it's pulled, but I have a feeling it's okay. Okay, well, our transistor tests as a diode. So we, in fact, have a faulty transistor. So I'm going to have to look this one up. This is a 2SA838. So let's see what that is. Okay, false alarm. Tony was wrong. This just wasn't in the tester properly. So it's not bad. Let's move on. Okay, I've noticed, here's your output of the FM detector. Here's the output of the AM detector, TP3 and TP4. So this is the top of resistor R43, which is going to be your, this is the output right here through this decoupling cap, or this coupling cap, of your audio, your detected audio from FM. And here's detected audio from AM, which is R39, which is TP1. And if we have AM broadcast selected or shortwave selected, which I have AM broadcast right now, we should have a signal path through here, all the way around here. And you can see it comes across this line and it meets same place where the FM is, and then goes down in. So technically, now that I have AM selected, I should be able to touch R39 right here with this probe, and it should buzz because it's going straight into the audio amplifier. Now here's the thing. If I look down here, there is your two detected outputs, R39 and R43. So there's 39, which is going to be our AM detected, right? So if I touch this, I have nothing. But if I touch the FM detector, I have an output. And that's kind of strange because I have AM selected, so I should have a clear path through to here, and I don't. And that is quite strange. to say the least. Now, there's really nothing else in there other than this switch, these switches right here. So am I losing my signal somewhere? I don't know. But what I can do is I can try jumpering this pin to this pin. So let's do that right now. Let's take this and we'll jumper it right to here. And do you hear that? We have radio. Okay, so let's turn the volume down so we don't rip our eardrums out. And let's put a little jumper clip from the one to the other. Turn the volume down, and if I bring my signal generator and there it is. Huh. We have a bad switch somewhere, it looks like. You're not seeing a darn thing, are you? So there you go. And now, and I have all kinds of volume now. Take this jumper off and it goes away. We have a bad switch, folks. I think that's what's wrong. So let's dig in and see where the problem is with our switch. I sure hope that it's not over here. This would be absolutely horrid if we had to work on this, simply because all the front end of the tuner is in front of this board. You'd have to disassemble all this. It would be such a pain to get in there. Okay, I really couldn't stand this schematic anymore. So I was able to go into a paint shop and stitch the two pages together, clean them up, despeckle them, all that sort of thing, and then print it out on a big sheet of paper so that my terrible eyesight can have a chance at seeing this. And things started to make more sense. If you look at these notes, S8.2, S4.2, S10.2, there are notes down here in the lower corner. And if I look down here, you can see where it'll say, for instance, S8.2, S8.2 BFO switch is off. So this is the BFO switch up here. S4.2 crystal marker 125 kilohertz is off. So again, S4.2 is right here. So again, this is the crystal marker switch. And then the S10.2 is the 500 kilohertz crystal marker, and that is off as well. So we were barking up the wrong tree, or should I say I was barking up the wrong tree. It was not the band selector switch that this is, but actually the BFO and crystal marker. So really, when we jumpered these two resistors together here, I could have done that, and it just would have made the BFO and markers not work properly. So we're losing our signal somewhere in those switches, and that makes sense now, because if you look at it, these are the switches that got really terribly corroded. If I focus in on it, you can see, even after cleaning this a lot, you can see how much crud is in there. So I'm going to have to remove this switch and see what the heck it is that's, and you can even see this thing here probably should move. I don't know. But we're going to take this apart and look at it, and we're going to try to get it cleaned up and see if maybe that is the problem. Okay, I'm going to repeat this another time, but this time with my microphone on. So we have to remove this marker dial here, and there's a very tight C-clip that comes off. And this is just friction fit. You have to just be careful not to damage it. Just be very... see here. There we go. And then there's a wavy washer under here, and you can see here's your two markers. the 500 kilohertz and 125 kilohertz. And you can see when you move this marker, this little pin comes around and it grabs a notch on this and locks this in position. So, and you can read the instructions how this all works and why it does that. But I'm going to clean this up in here, but now that we can get this out, I can get to these screws here and remove the switches, and you can see just how cruddy these are. I think this is where our problem is going to end up being. Oh boy, I think I see why we're not getting any continuity through that signal path. Look how cruddy that is. Look at all the corrosion in there. These switches are just ruined. So I'm going to have to try to take them apart, and I will desolder them from the board, and we're going to see if we can get them apart, you know, far enough apart that we can clean them and hopefully fix this. I don't know. We'll see. Oh boy, the more I take this apart, the worse it gets. Look at that. How did that corrosion get in there like that? Well, after 24 hours in evaporust, let's take this thing out and see if it cleans up. Okay, so these two outer switches, this side and this side, here and here, seem to be okay. If I move the switch this way, I have connectivity. Go to this side, switch it the other way. It's good. This middle section, however, this is where that just thick, heavy corrosion and rust was. And you can see, I do have some connectivity here now. So it might just need to be cleaned out because there was a lot of gunk that washed out of there. Okay, it's working. You can see there's a little bit of that should be almost infinite right now. So there's still some gunk in there. But possibly we may have gotten some results. Now see, this one doesn't do anything. So that part is bad. Okay, looking inside here, these contacts actually look to be in decent condition. They just have a lot of that gunk in there that we need to finish cleaning out. So let's finish cleaning it and see if we can luck out on this one. Well, I gave it my best shot, but these things have worn so thin that they're just falling apart. They won't stay tight on these pins. So even though the rest of it will work, these little slide springs are just corroded beyond repair. So I think we're going to have to go to our parts unit and take the one off of that. And this is just beyond repair. I do have a at least a partial complete parts chassis. And you can see it does have that switch, so we can harvest that if we have to. Folks, this is why you do not leave batteries in a battery portable radio like this. This is what it'll do. I mean, it's amazing how that battery corrosion gets all over the inside of your radio and just ruins it. Okay, the new switch is in, and it was also crusty and needed cleaning. And wow. This must be the Achilles heel of this radio, because both sets, that first switch was legitimately corroded from battery corrosion. This one doesn't have any battery corrosion, but the terminals were still filthy and they needed to be cleaned before they would work properly, but they test good now. So I have the loop connected up. I have this put back together. Let's turn this on. And it works. We can hear it. And there's all kinds of noise you're going to pick up from the bench. But I'm at 1 megahertz, so when we get to here, we should get something. And we do. band, wideband. It's working. I think we can finally put this back together. Well, we got a little bit of short wave going on here, and we have some single sideband with the BFO on.
And that wind is still kind of gusty here now, but still a pretty nice thing. We can finish some working fine stuff today. The friends come over, and I got my 160-meter dipole back up that tree.
There we go.
I had one end tied in, and I had to move it to a different tree. And
nice. You can see how sideband is so difficult on these kinds of radios because they're really not ham radios, but as you can tell, it works. And you can see when it's sideband, the meter only deflects when there's modulation, whereas with AM you have a continuous carrier, so you can see that. It's nighttime right now, so we're picking up a lot of things. We're clear down in the 80-meter band, I think. Well, we're a little bit above that, but and there's some AM shortwave.
Ladies and gentlemen, the day of the Lord is at hand, and Jesus Christ is coming. 1, 8, 4, 3.
Some digital. So yeah, we got all kinds of stuff here. FM.
To help school those of us that haven't done a lot of self-journaling, we've done it.
Now, I'm not going to get any AM down here because there's just so much interference down here right now. I'm just going to get that buzzing noise from everything. It's just going to overpower everything, and it's probably, it could be my camera, it could be anything on the bench, it could be this stuff running behind here in the basement and like the washer and dryer, any number of things. So we're not going to get AM, but it does work.
At the door, 1 hour, 49 minutes, coordinated universal time.